Hello, my name is Gerhard Dorn and I want to take you on a journey, a random journey, across the ocean of uncertainty with Captain Base and her crew. But let's start step by step. This talk is about how to use storytelling to teach online, and especially how to do this with interactive Pluto notebooks. So there is this course on probability theory at my university, and in November I got the chance to transfer this lecture to the web. More specifically, to create a MOOC, a massive open online course that basically allows you to deliver the content as a video and with some interactive parts, and you can check the learning progress of your students by having online assignments. In the pandemic, there are more and more courses, lectures go online, and there is a huge market, and what they all have in common is that online means there is a video or at least some interactive part. But from my experience, when most lectures went online, you see in video conferences, most students are passive. They switch off the cameras, you don't reach them. You lose students. And one reason is that there is this digital barrier with video, and the question which really intrigued me was how to reach the students, how to motivate them, how to activate them. And this is the word activation and also interactive parts, which is a reason why I really love Pluto notebooks. And yeah, how to reach people. It's emotions, and emotions are no weakness. That's the first language humankind learned to reach out to other people are emotions. And if you combine the lectures, the contents with, you don't have to get feelings like hate or anger or to fall in love with the integration operator, but at least make it like a story. So storytelling is the best way how to deliver content. And as you can see, I also used some emojis which appear not to a bit stressed, but those emojis also help to deliver or to make at least the texts more colorful. So human beings consume content also with their eyes, and if you provide them with symbols, with figures, it kind of helps them. And you will see also in the Pluto notebook I will present later that I use lots of emojis. And for those using a Windows computer, I found something really cool. Michael told me recently, just press Windows key and the dot, and you will be surprised to find the emoji keyboard on your computer. So this is a way which you're really fast in using emojis. So after having a story and being able to reach the students, you want to activate them. We had this working group at my university which was wondering that so many students didn't do the exam in the end and are not active in doing exams. And from my perspective, I always see a lecture is a passive process where you got delivered the content, and it's a passive process. You just sit there and watch and listen. But then in the end, you have to be active. You have to reproduce the knowledge, you have to do assignments and so on, which is an active thing. And the question is, how do you get from this passive state to an active state? How to activate students? And there are interesting ways how to do so. So you have to let them think, you have to give the students tasks, you have to foster the interaction between students. And from my perspective, in the learning concept which we experience at universities, there is this step of activation is somehow missing. So in my perspective, there is three phases in learning. There is the knowledge transfer, where you sit in the lecture and get the content, which nowadays perfectly can be online. And the second step is you have to deal with the subject as a student. You have to question it, you have to discuss it with your colleagues, you have to work with it. And this is a step which, in my perspective, is missing in most curriculums, or at least really is missing in the pandemic, because students don't have the learning groups. Students don't have the possibility to ask a professor after the lecture, go to him, ask a question, and to meet other students at the hallway and so on. And this is the question, how can we transfer this to digital teaching and online teaching? This interactivation, this activation of students. A good thing is, which I experienced and which I will show you in the course, are H5P content videos where you have a video and then the video is stopped and then you have a question which relates to the content you just saw, and you have to think about, how do I apply it? How can I work with it? And so on. And the second thing are Pluto notebooks, where you can also go step by step through some calculations and do some interactive sliders and so on. And this also kinds of helps in the second phase. The third phase in teaching or in how you learn is the application of knowledge, which are the classical exercises, the laboratories, where you have to do some homework, where you have to do some project, where you code and create a new program and so on. And yeah, I will show you, I didn't do this third step a lot in the course now, but I tried at least to help to activate students with Pluto notebooks and storytelling. So let's look at this MOOC course, and I wanted to show you H5P content, how you can combine a video with activation questions, and I want to show you how we use a story in a Pluto notebook. So this is the website of the MOOC course, and you can see we structured it in 9 units and use a story to motivate each topic. I will show you how we use H5P in the lesson videos, and later on how we use Pluto notebooks in the Odyssey and Stochastic processes. So each unit is introduced by a story. The story is Captain Base and her crew. It starts actually like a computer game. And in the story, on the second, the average yields southwest. But if a question, a problem is motivated, and later on, below, there is the lesson where you learn how to solve it. The H5P activation contents are within this lesson video, where you have a topic.
Or repeated throws of a single die.
In this example, it's set theory and events.
Of the sigma space.
And you see a question pops up. So you see the video, the passive phase, then you have a question regarding the content you just watched, which elements are part of the sample space omega of the experiment compass and dice. So, well, I have a compass, it's a direction, and a dice is a number. So I take this one and this one and see if it's right. Yeah! Here I want to show you the 6 steps we use when designing a Massive Open Online course using storytelling. First, you have to think about the skills you want to deliver in your unit. Second is you have to find a problem that makes the skills necessary to solve the problem. Third is a story that motivates the students to solve the problem, or actually that makes the students want to solve the problem. Fourth is the content, where you actually deliver the skills, which is typically a lesson video or something like that. Fifth, activation, where we actually use H5P items to stop the lesson video and make the students apply what they just have heard. So these immediate questions were activated. The sixth step is interactivation of students by using Pluto notebooks, where students can run simulations, change parameters, and also motivated to change the code. Before showing you the interactive Pluto notebook using storytelling we made, special thanks to Johanna Moser, who created most of it. So here we are, welcome to this random journey. Each day we choose the sailing direction randomly. So Captain Base and the crew, as already told, want to do a random walk on the ocean, and now you should help her to dial her famous random compass. And you should press this dial. Let's see what happens. Okay, cool. This is the compass. So we got the direction north, and here you see, okay, initial position. Okay, we sailed one step further. Then, yeah, I think we should dial again. East. Cool. So we went east. So for those who are interested in how we do this, check it out. So Fonts was so cool to create this button, which, yeah, you can have a look at. There is a function called click counter with reset. So it counts how many times you click, you get a state, and then you can reset it. So we have 2 steps now. You continue, next, again east, and yeah, the graphics, these are GIFs, which are stopped, and those are the GIFs. And depending on which result the random generator produces, so 1 to 4, you get one of those directions. So north again, east again, north, west again, and okay, this is Ernesto the parrot, which is the learning buddy. So he says, thank you for helping Captain Base dial the compass. Now she can it on her own. And after doing this first work, so this was the activation, and here are some thoughts why we did this step by step. You could create a Pluto notebook and present everything ready. For example, if I scroll down, you can see, okay, here the random walk takes longer, and I have a slider where I can change the days, how long, where is the final position after 160 days, and I also can change the seed. So let's look at another random walk. Looks totally different. And I also can go back and forth, which is kind of cool. See, he is kind of returning. No. And why did we split this notebook in these steps? We experienced that sometimes if you deliver the whole simulation to the students, they don't get it. It's just, okay, I have a slider, I move the slider, I see a Gaussian curve, but I have no idea what's behind. And you have to somehow make this learning experience comprehensible, going step by step. How is it going? And this is designed so we don't record this and we don't make a video and show them how to work with this Pluto notebook, but we just give them the Pluto notebook and they can work on their own. So there is this narrative, the story, first dial, then see the individual steps. Then the next step is you found an old logbook where you can see how previous random walks works, and there are many books in the bookshelf, and changing the seat is taking another book out, and you can see, oh, it seems that we got the return here. Very cool. So when the green dot reaches the red dot, we have a return after 89 days. Very cool. And yeah, we made a lot of things. So it goes on, the story. Here again, you can see our compass. Now you can change the probabilities, maybe cheating a little bit. Let's go maybe a little more to the east. And this takes some seconds because we do some other, no, it's done already. You can see the random walk rather goes in the east direction. And let's see different, at least you can see the drift. Well, let's see a small episode out of the new video about Bernoulli and how he's feeling on the ship.
So, in which direction are we sailing right now? Left or north, right? I'll just draw randomly. Oh no! The journey makes me so weak and clumsy that I spilled all the ink on the map. Now we can watch the lines fade under the ink dispersing.
Bernoulli, how wonderful you draw the average course of this random journey. The darker the ink, the higher the probability. The fusion must be a random walk too.
So now we saw how Bernoulli spilled the ink on the map and how Base concluded that this ink could indicate the probability distribution to find the ship on the random walk after some days. And in the Pluto notebook, we can actually investigate this. So the next section is dedicated to this probability distribution, and you can take 3,700 random walks, for example. You can change the number of days they sail, and you see the frequencies, how often, where does the ship end, which is kind of this ink stain. It's not a real ink stain because you have this chessboard pattern, which is because on an even day you just reach sites which are an even number of steps away and so on. But you can here average 2 consecutive days and you really get a pattern like an ink stain. So we prepared this for the students and matched the story which motivates the problem of a 2D random walk and make it comprehensible with a Pluto notebook. Yeah, here Ernesto is the learning buddy, invites you to take a break. And next I want to show you some seconds how we introduced some joke and which spices up the story, and also we introduce smallpox and the Simpson paradox, and see also how Bernoulli is feeling after this letter.
The first type using smallpox pulses proved to be more effective in both cities, but the second using smallpox pus seems to work better in total. Paradoxical, isn't it? Take care. P.S. Don't drink and derive. Newton has had an accident recently. Leibniz was so very mischievous. Your loving brother, Thomas Bayes.
Don't tell me about diseases. I even feel the smallpox popping up on my back. Ernesto, I am so seasick. Or even worse, I might suffer from scorbut. I think I need some citrus fruits to prevent myself from losing my teeth. Why can't we just sail to that cute turtle-shaped island over there and enjoy some fresh orange lemonade on the beach? It looks just 5 days away.
Island in sight! So now let's help Bernoulli to reach or to examine the problem of reaching Turtle Island, which is 5 days away, with this Pluto notebook. Here you can see again that Bernoulli is not feeling well and wants to have some lemonade. And below you can see 1,500 walkers, and when they reach Turtle Island, or on the right column you see they did not reach Turtle Island after 20,000 days. So Bernoulli is sad that it takes so long, and you can help him to manipulate the compass, if Captain Bayes does not recognize, so to reach it faster. And for example, if you switch this to 0, north and south directions, you get a random walk in 1 dimension, and you can see the distribution here in a second. 1-dimensional random walk, and the first arrival is after 59 days, at least the median is 59 days. So this is pretty cool, at least for Bernoulli, if Captain Bayes does not check. And you can also simulate this with Markov process. So this is the isometric random walk 2D cumulative probability. And here you see how the Turtle Island is absorbing all walkers which just got there. So I hope to have given you some insight in how we use Pluto notebooks and storytelling. And if you have questions how we realized it, just look into the Pluto notebook. You can see most of the tricks there, or contact me and ask questions in a Q&A session. And I want to wrap up my presentation. So take-home messages for you. Storytelling as one of the oldest forms of communications is super important and helpful also in teaching. It not only motivates the students, but also the teachers, as my professor was super motivated in also writing stories and creating very cool Pluto notebooks. It kind of fosters the creativity also of the students, and Pluto notebooks help a lot in this activation process. So from just consuming the content and going to programming and change things on the self. So what we didn't do is a programming course with Pluto notebooks yet, but I see a lot of potential to do that. I really like Pluto slider server. So with 1 click you can change and try the simulation, and with a 2nd click you can open Binder or download it and change the code, and no email address required. You just need 2 clicks and you can code. The next step in storytelling would actually be a computer game. And I already thought about a click and point adventure, which is the exam actually of your lecture. So you do a game, you collect items during the course, you get a torch, you get the dice, you get a rope, as if you solved problems in the lecture or in the online course. And then in the end, you have a time-limited computer game, click and point adventure, where you have to solve problems related to the course, and in the end you get a grade. And I would be super happy to be able to, or to have the possibility to create such a computer game exam. So if you want to finance me, just do it for creating such a thing. With this, I want to thank all those who made this course possible. iMOOCs, fonts, and his Pluto notebooks, they're really awesome. And yeah, this is the team behind. We have pixel artists, video animators, students who help in creating this interactive simulations, setting up Pluto slider server, and writing the stories. Thank you so much.
Oh my God, that's
amazing.
Thank you.
really, really incredible. It's so exciting to see this being used, and it's, I think, very exciting for me that we used Pluto for the situation where students run code, but you used it exclusively for simulations online, which is so cool. I guess maybe the first question that other teachers would have is, but this takes so much time to do. So how were you able to spend so much time on one project, and how do you see the future of teaching in this way?
So I got the chance to work like full time on this project, and it's like just a 6-month project to create such a course, and it's a lot of work, but we got so many motivated students who help us in creating it, and they also learn a lot with video editing and also coding. And the future of teaching, I hope more courses are approachable like that, so students are more motivated, and the feedback from students is quite good. So they like the stories. They also think that the content video, which we also create, work very well. So they like it.
How old are the students that are getting the course?
So they are grad students, so physics and biomedical engineering, and yeah, 4th semester, I think.
Do you feel like making a course in this method also changes the way you think about these mathematics, or how you're supposed to teach them?
Yeah, the thing is, if you have to teach things, you always really understand those topics, and so it helps me a lot to think more about that. And you come up with different ideas how to look at the problems and which applications they could have. And so this kind of links you more to the real world. This is also cool if you can apply those concepts, mathematical concepts, stochastic random walks, Bayesian probability theory, and so on.
Really cool. Can you compare this to other tools that you might use for this purpose?
Yeah, you could create a homepage, but then you cannot change the code. So we had a professor just using JavaScript things, and they didn't work that well. And I really like, so that the real cool game changer is that the students can take the code and use it for their own project. And we work a lot with student projects where they do a small programming project, and they create actually the teaching content for the next students to come. And so this is a sustainable kind of teaching. The work the students are doing is not lost. And this is the thing I really like. And I mean, Julia is super fast. So if the students need that for a bachelor project, they look, hey, I got the code there, and then they just can put things together. So this is the promise of Julia, having a language to speak between the people. I really liked it.
That's awesome. Okay, thank you so much. I think a lot of people will be inspired by your talk. Next up, we'll go to Jingwo, who is talking about tropical tensor networks for solving spin glasses, which sounds super exciting. All right, thank you, everyone.